Welcome. My name is Carl Tape. I'm an earthquake scientist at University of Alaska Fairbanks. These slides are part of a set of recorded mini talks for the earthquake sections of the course Glaciers, Earthquakes, and Volcanoes, GEOS 120, offered at the University of Alaska Fairbanks. This video provides some background material needed to better understand the video series on Alaska earthquake science facts. Welcome. This section of the course is all about earthquakes and earthquake science with emphasis on Alaska. Here's one of my favorite views of the Earth. It's looking down on the Arctic regions. So the North Pole is somewhere in here. What you see is Alaska and connected to North America. The dots are earthquakes. They're colored by depth. We'll get to that part later. But what you see is that earthquakes don't occur everywhere on the planet. They're actually pretty localized in certain regions, and they actually define the plates, the tectonic plates on the planet. So you are here, or at least I am, here at University of Alaska Fairbanks. And we see the plates, the North America plate that Alaska is part of, the Pacific plate, the Eurasia plate, and here we are in Fairbanks on the North America plate. If we zoom into Alaska, we see tens of thousands of earthquakes. Here we are again, right in the center of the state. Each year, there's something like 50,000 earthquakes that are recorded by analysts here at the Alaska Earthquake Center. We zoom in here, if you see in the lower left, the field of view, again, still lots of earthquakes. Welcome to earthquake country, Alaska, here in Fairbanks. If we look at the earthquakes in the United States, we see Alaska produces the vast majority, or 84% of earthquakes in the United States. The next state is California, coming in at 10%. And so this is a fact that is not well known, mainly because there's not a lot of people that live in Alaska. So the earthquakes don't have the same consequences that they might in dense urban regions of the other parts of the country. If we look at earthquakes, the largest ones ever to be recorded in the world, top 13 earthquakes ever recorded, we will find 4 from Alaska: 9.2 in 1964, 8.7 1965, 8.6 1957, 8.6 1946. So 4 out of 13 earthquakes, largest earthquakes ever recorded, are in Alaska. Not only is it a dominant earthquake producer for the US, it's a dominant producer for the world. Well, what can earthquakes do in Alaska? Here's an image from 2018, northwest of Anchorage, a road west of Palmer, Wasilla. We can see the car that was on for quite a ride through this earthquake, presumably. You see people standing there for scale, and this is sort of a stereotypical image of some kinds of effects, in this case very localized, but this is gives you an idea that when earthquake waves interact in certain cases, there is really nothing to stop them. Man-made things are not going to be a match for the kinds of energy that gets released in earthquakes. This road would be one example. Here's a video. You should really watch this on YouTube to get the audio, because the audio is kind of the best part, but I'm not going to play that here through Zoom, but I'll run the video. So it's a live classroom in the morning, and you see the shaking start, and within about 2 seconds, everyone is under the table. You can see the shaking picking up. There'll be some stuff fall from the ceiling there on the right. Power goes out. Anyway, check it out, especially with the audio. Here's an image, March 28th, 1964, magnitude 9.2 earthquake. This is downtown Anchorage, and this is the road level. And you can see people for scale, cars down that have been part of this landslide or very localized strong deformation from shaking caused by this earthquake. Just a spectacular view of what kinds of effects can happen during a really large earthquake. Here's a view from Black Rapids Glacier along the Denali Fault. You see that this glacier, which the fault runs under here in the Alaska range, it should be white, mostly white, but the shaking effects have caused landslides coming off of these mountains and blanketing the glacier shown here, even going all the way across this valley and partly up the other side. The picture conveys not only just the sense of scale and size in Alaska, but also the sense of strength of these kinds of earthquakes. This is a 7.9 earthquake, November 3rd, 2002. 1958, Lituya Bay, southeastern Alaska. This is Lituya Bay. And this was the site of a 7.8 earthquake. And there's so much to this. The earthquake came along a fault that runs under Lituya Glacier here, kind of from left to right. That is the plate boundary between the Pacific plate on this side, and in the background, that's the North America plate. So it's a major feature. And along that, these glacier runs and the shaking from that earthquake set a rock slide that came into this deep fjord that's been carved by the glacier. And what you see here, this bald kind of barren area, that is the forest, a healthy large forest that's been wiped out by the mega tsunami caused by the water just being splashed out of this bay. And that point, just to give a sense of scale, is 1,720 feet or 524 meters above sea level. It's the highest wave ever recorded on the planet. And this happened in association with a 7.8 earthquake in southeastern Alaska. So just looking at a picture like that, we want to get into understanding how did this happen, what's the setting, and just appreciate the forces involved, not to mention the stories of the boats that were in the harbor when that mega tsunami wave came out. Here's a picture of the setting for Alaska. It starts to be a three-dimensional view. We have Alaska on its side, Canada in the background, and we have this Pacific plate goes underneath the North America plate. This is called subduction. The Latin roots sub, under, and duct, lead. Subduct meaning to lead under. And this Pacific plate going under Alaska is responsible for the 9.2 earthquake from 1964. It's responsible for the volcanoes shown here. It's responsible for the strike slip fault on the Lituya Bay earthquake that we just saw. And so this is a key setup for this class, is thinking about the setting for Alaska, the Pacific plate subducting under North America. And so we'll play this video. I'm going to slow it down here so that we can kind of appreciate it more. Here's kind of a three-dimensional view of Alaska, cutting away this Pacific plate. And then we're going to slice it right down under Anchorage, basically, and take a look at what's going on. So zoom in. Here you have the Pacific plate subducting, going under the North America plate. And this friction on this shallow contact, that's the fault that broke during the 1964 earthquake. Caused a tsunami, caused extremely strong shaking, including that photo from Anchorage. The same process as the plate bends, you also get other earthquakes inside. That's like the one formed in 2018, just northwest of Anchorage, the 7.1 earthquake that showed that video of the car. Here's a picture of earthquakes in Alaska just for 1 year. This was 2019, but you get a sense of some, 40, 50,000 earthquakes and all the sort of pockets of features that might happen during 1 year. Here's an animation showing that. And you can kind of see as the year goes on, this is February, marching on, and you can just see in some cases you might fill in a new dot, but in general, this is what very sped up 1 year looks like. We're at 20,000 events in June so far. You can see the clock ticking up. You can check that out on YouTube. Here I am. I'm in Geophysical Institute right now. This is a West Ridge, part of Upper Campus, University of Alaska Fairbanks. Beautiful photo shot from the fall here. And to me, what I see in this photo is quite different. What I see is all kinds of things related to earthquake science in Alaska. We have high performance computing, seismic data acquisition, Alaska Satellite Facility, dishes, International Arctic Research Center, infrasound, seismology, geodesy, volcanology here at Geophysical Institute, infrasound array for comprehensive test band treaty monitoring of nuclear activity. There's global seismograph station in the woods out here, and even at the Museum of the North hosted a virtual exhibit that's available online, Shake Alaska. So a lot of activity coming here. I want to mention some of these resources that are online. This is earthquake.alaska.edu. There's all kinds of cool things to look at. We'll explore later. Should be aware of this. There's also this museum exhibit really focusing on historical earthquakes in the interior. I encourage you to check that out, especially if you're interested in history of Alaska or science history. And then we're really setting ourselves up for a series of 25 amazing facts about earthquake science in Alaska, but we need a few background videos in order to really sort of have the right context for approaching those videos, but that's where this is all headed. So takeaway, Alaska produces the majority of US earthquakes. Earthquakes occur because of plate tectonics, which describe the creation, destruction, and motion of approximately 100-kilometer thick plates on the Earth's surface. Alaska is on the North America plate. The Pacific plate subducts underneath Alaska.